This talk is sponsored by IPFS and Filecoin. IPFS and the Filecoin Foundation are fully distributed open source organizations that aim to help radically improve the internet and drive breakthroughs in computing, which can help move humanity forward. Learn more at filecoin.io and ipfs.io.
Good morning, all, or maybe I should say g'day, blockheads. Sorry, don't hurt yourself face palming there. I'm Ali. I'm Australian, in case you couldn't tell by the accent, and obviously I have a terrible sense of humour. Luckily, though, it's not my day job, so I'm actually a developer advocate here at Filecoin, which means really I get to work on my passion of helping enable others to build out their ideas and supporting developers like all you amazing folks on your own journeys. And I also get to be part of this awesome ecosystem and what I see as really the ultimate open source project in public blockchain and Web3. So I love hackathons because hackathons are an amazing way to harness the power of community and innovation. And they really kind of capture the spirit of why I got into tech in the first place, which is the impact that innovation can have. And the capability for tech to help transform our lives in really amazing ways, as well as how our society functions. And it like kind of can redefine and create new industries, new collaboration paths like DAOs, for example, and it can help us solve some really complex problems. So congratulations to you all for being here today. Firstly, I guarantee if you ask any founder in this space or even in the tech space how they started out, they'll say they did a lot of building in open source or at hackathons. So you never know where this can take you. And by the way, this is my Genesis Devs for Revolution NFT. A bit of a flex there, but I'm pretty proud of it. And honestly, it still amazes me how much has happened here and how much it's like grown in such a short space of time. So I'm here to talk to you about everything to do with IPFS and Filecoin. So I'm going to get on with that now. Firstly, though, the timestamps for today, so you can go back and check out the bits you're interested in. Firstly, I want to go through IPFS and Filecoin, some of the concepts, the tech and the dev tooling that's available. I'm going to check out some use cases and some of the awesome projects that are already building on IPFS and Filecoin. I also want to share some Filecoin and IPFS social good projects with you. And finally, I'll talk about some of the possibilities and opportunities, as well as what we've got coming up in the pipeline. I'm so excited for the future, for this year especially. And then finally, I'll just share some resources and how you can get involved and stay in touch as well. So a lot to fit in this short talk. So bear with me. I will do my best not to overwhelm you all. But anyway, I'm also joined here today by Biscuit, the Filecoin corgi. She's also on my thing there. But Biscuit's a great doggo, and she'll be helping me with the prezzo today if she doesn't run away with the Filecoin frisbee and to the park again anyway. But that's a story for another time. So the first thing I want to get to is maybe there's a little bit of confusion around some of these names that you've seen out there. And that's warranted confusion because they're all tightly affiliated. But I just want to clear this up. Protocol Labs, IPFS, and the Filecoin Foundation, you've probably heard them used interchangeably, and that's not unfair, as I said, because they are tightly affiliated. But they're actually all separate organizations working on a kind of separate vertical in this space. So Protocol Labs, which was founded in 2013 by Juan Benet, and he's awesome, by the way, go and check out some of his talks. It's a fully distributed open source research and development organization. It builds protocols, tools, and services, and it aims to its mission is to help radically improve the internet and drive breakthroughs in computing, which hopefully can help us move humanity forward. So there's some massive goals there, and both IPFS and the Filecoin Foundation, which were two projects that were originally incubated by Project Protocol Labs, but as I said, are now separate organizations, both take that mission to heart as well, though. So the original white papers for IPFS and Filecoin were released in 2014 by Protocol Labs, and they've since spun out in, I think IPFS was 2015, it spun out into its own entity, and Filecoin was only recently released in 2019. They had their mainnet release. So we're still young and early here. So hopefully that clears up a bit of confusion, as well as when I get into the difference between IPFS and Filecoin, how they're complementary but fundamentally different, that will help as well. But one thing to think about, if nothing else, is that IPFS is a peer-to-peer version of HTTP. There's no blockchain, it's a protocol. Whereas Filecoin is a blockchain, and you can kind of think of it like the Airbnb for storage. But hopefully as we dig deeper, that'll be a bit clearer, and hopefully I've cleared up a little bit of confusion there. So obviously I'm here to chat today about all your storage needs. Okay, so maybe that's not the sexiest opener, and it did sound a little bit like an infomercial. But in reality, though, storage is essential. Like data storage is essential. If we have a look at, data, information, and knowledge are some of the most important assets of our connected era. Pretty much nothing can run these days without data. So for anyone that's played in the ecosystem, you'd know it's an absolutely essential part of things. And it's also, not surprisingly, a super fast growing field in Web3 because enabling distributed storage mechanisms that also have distributed storage at their heart can really help us build out more use cases and applications with permanence, with trustlessness, and with fairer and more resilient outcomes at the forefront. So I think everyone here has probably got a really good understanding of why they're listening to a talk at Developer DAO and why you're passionate about being part of what we're building here. And there's so many different reasons which have brought us together. And this diversity is another one of the most awesome things about this space, including the sheer collaboration of effort going on. But one of the big pieces of the Web3 stack puzzle, though, as you might have guessed I'm interested in, is how do we store data in a way that aligns with this mission that I just spoke about, that's distributed, verifiable, censorship resistant, and it's owned by the people, but that still brings the best of Web 2 as we know it with it. So it's easily accessible, it's scalable, it's cheap, and it's efficient. So this is one of the core problems that IPFS and Filecoin are aiming to solve, and not just for the Web3 world, but also for the broader technology arena as well. Massive kudos to Nada. Everyone might have recognized this little chart here for kicking off this Web3 architecture mental model. I'm going to probably suggest that IPFS doesn't exactly belong in file storage, as I kind of alluded to before. It's a protocol that probably goes across the whole stack, to be honest, but Filecoin definitely belongs in storage, and not just file storage there, any type of storage. So spoilers there, but love this mental model, and it kind of helps simplify things and understand how we're playing in the ecosystem as well. Alrighty, so hopefully I've set the scene now. We're in a faraway land, blah, blah, blah. Let's get into the tech though. Let's go down the rabbit hole, down the matrix. So currently the Web 2 model, as we know, is centralization. There's really only a few companies offering storage. They include like Microsoft, Google, Amazon, also my previous workplace, IBM. If any of these fail, which we've seen happen countless times, entire services go down. So to solve this kind of resilience engineering challenge, you could start to, and people do, start to architecture with microservices. It's called, moving to a modern service. You could have multiple databases. You could maybe run something like Kubernetes containers and then put that on Red Hat and start creating a multi or hybrid cloud environment. But honestly, by this point, you're really diving into decentralization and distributed systems already, and just for resilience. And it comes with a massive engineering and financial overhead to do so. So really that leads to the question, why aren't we designing the web for the autonomy and resilience we need in the first place? And then how do we get to a world that has a resilient, performant, scalable, secure, efficient, trustlessness, censorship resistant, free and private, silo busting web? All those great words that we're after, and the ideal that we're after as well, because we know if we're not paying for a service, we're the product. So this is the exact kind of problems we're trying to solve at IPFS and Filecoin, and why we're so driven, together with the awesome community out there that contributes to all the open source that we do, to do this. So hopefully I can give you an idea of how we're solving these problems over the next 30 minutes or so. Firstly, I want to start with IPFS, or cue the Star Wars theme, please, Interplanetary File System. So this isn't just a meme name, though, because as a distributed peer-to-peer network, not a blockchain, of files and folders, you guessed it, it was designed to be able to work even when your network is between planets. So let's say you signed up for the Mars Colony program, you're now living happily on Mars with Elon Musk. Maybe it takes you an hour or so to request a file from Earth that you need. But the thing is, if someone else on Mars already has that file on an IPFS node, then that person can just serve that content to you instantly instead. So maybe you're thinking right now, well, this is just a fancy story for a peer-to-peer network, but there is real gravity, pun intended, in what it does, because IPFS is distributed by design. It has no central authority service, and it's designed to be offline first for resilience. So It uses a really unique and upgradable standard for addressing content, and this is really the crux of IPFS. It's the way it addresses content and handles that that is the big standout, and why it's so cool as well, and why it can be hard to get your head around a little bit as well. So it's unique because rather than using methods that we might be familiar with for storing and accessing content, so our HTTP methods, they're all location path based, and they all point to a particular HTTP address where the content there could, like we know, fairly easily change from day to day. So instead of this, location-based addressing, IPFS uses content addressing. This means that not only can you be sure when you're accessing an IPFS content ID that you'll receive the exact same piece of content every time, but you also don't care where that data comes from. So because you have your content as the addressed thing rather than your location as the addressed thing, it's kind of wild, right? It was definitely wild to me when I first started looking into IPFS and Filecoin because it's just such a mind shift from the Web 2 world, which, we've all become accustomed to. But it's also super elegant because shifting the focus from a location based address to a content based ID opens the web up to massively distributed storage solutions and that resilience engineering challenge we were talking about. So it's also the reason, because this CID is immutable, this content address or content ID is immutable. It's also the reason for all those warnings you might have seen on ERC 721 templates or otherwise known as NFT implementation blogs. Because if you're not storing your NFT metadata on chain or with IPFS on an immutable content ID, then generally it kind of no longer carries the essential value proposition of an NFT. It's no longer verifiably non-fungible. That's just a quick example though. So let's see how this actually works in practice though, diving into the matrix here of how content addressing works. So in order to create a content address, which you can kind of also think of like a cryptographic fingerprint, which I find is a nice analogy because every fingerprint is unique. We use a cryptographic hash function to create a content identifier, or CID for short. And for each piece of information that we want to put on the network. So this means that every piece of content has its own unique CID, content ID, of the same size, regardless of the amount of content it represents. And importantly, this CID can be reproduced anytime from the original content. And so we can always verify that the content we've been given is exactly what we asked for and what it was originally. It's immutable. And just to quickly note as an aside here, the content addressing system works for all content, including, for example, folders. It's not just limited to a JPEG. We can even represent a full file system using a content addressing structure. So again, kind of wild, right? Because I actually do still like JPEGs and, a picture speaks 1,000 words after all. So here's an illustration of how that works. This is a content addressing graph, or what we call a Merkle DAG, directed acyclic graph. Got it out. We're definitely in the matrix now. But this is really just a fancy word for a type of data structure. And the main point here is these Merkle DAGs are what allow IPFS to move from location-based addressing to content addressing in a single step. And that's by replacing locations with the root CID of their content. The subpaths stay the same. So let's work through an example of that. Let's say we wanted to copy biscuit.png to the folder of the second user. Yep, Biscuit is here to help, not at the park. Firstly, we don't actually need to copy this file though, because two copies of the same content have the exact same identifier. So to IPFS, they are the same thing. We call that deduplication. I know, another matrix word. But instead of copying it then, we just have to modify the containing folder, where we want to copy it to, that containing folder, to reference the content, and then we propagate the new content IDs of that folder up through to the root CID. So there's no need for a centralized server to provide the trust mechanism of data verification any longer. And that's a super important point. So alrighty, you can make a bunch of content. Let's move on to how we retrieve stuff. Something Biscuit knows a lot about with those frisbees. I know, I won't give up my day job for a comedy gig. Anyway, we do this with a peer-to-peer network. So each peer in this network also has a unique identifier. These are called peer IDs. And this is again, of course, linked to a cryptographic identity, and which allows each peer to communicate securely through an encrypted channel. So that's important as well. We can encrypt things on the IPFS network. So as you can see in what looks like a Star Wars path tracing mission diagram above, Forget for a moment about IPFS and maybe think about a group of people. If I want to address a person and communicate, it helps if I can identify them, for example, by their name, and it also helps if we share a common language so that we can communicate, like English in this instance. I'm learning French, but I'm terrible at it. But let's start with English. And if we have ways to verify that we are who we claim to be. So this is the same with IPFS and the peers in the network. Each peer has a unique identifier. This identifier is linked to a cryptographic identity, English, and this allows each peer to communicate securely through an encrypted channel. So that's how it works. In order for peers to be able to discover each other and the network transports they support, we use, though, because this is the second part of this, we use a distributed hash table, or DHT. So you've probably all here heard of a hash table, you're developers. So the distributed version isn't too different apart from the need for multiple peers to maintain it because it's distributed. So in order to get the value associated with a key in a DHT, in this case the content ID, a peer asks other peers in the network who has this row. It's a bit more efficient than a general broadcast though, because peers with certain names or peer IDs are more likely to contain certain rows. And we're deep down the rabbit hole here. You can definitely see more in the docs about how this actually works. So I won't go too much into it. Otherwise, I'm going to end up saying peer, planetary, and pickled, or no, picked a lot, hence the bonus tongue twister. So definitely dive into that. But basically, a peer can ask other peers in the network who has the content we're looking for. So IPFS can now use this distributed hash table as a database, and when either a CID or peer ID is added to IPFS, a peer can insert that row with some extra query info and therefore declare itself as a content provider. And all of this protocol and networking logic is kind of what makes IPFS a really important and valuable protocol, and not just for Web3, but also for tech use cases in general. And I'll show a few of those in the use cases segment here. But it's just a super kind of simple but powerful tool that we can kind of change the way the web works with content identifiers instead of using location identifiers. So as certain pieces of content, so what happens in IPFS though is as certain pieces of content get more popular, the data becomes more readily available and resilient. And fun fact for those of you that watch Silicon Valley as well, the Pied Piper project in season 4 was actually loosely based around IPFS research and talks. So pretty interesting. When I found that out anyway, I was like, wow, that's cool. Cool nerdy fact. So now we kind of come up against this problem though, and it's the same problem that the early internet had though, because there's no real permanence to data stored on IPFS. Because why would random people help to store, even with pinning of our IPFS data that we put on there? Why would people, store our digital content? The answer is, unless there's a personal incentive for them, maybe we pay them, or maybe they like you, or maybe that data is super popular and they like the data you create, so they'll keep it around. But generally, the answer is, there's no guarantee that this data is going to be stored forever unless you do it yourself. So despite the usually good intentions of a community, less popular pieces of content will probably stop being hosted and will no longer be able to be retrieved. We've kind of all experienced this with torrenting networks as well. And torrenting networks is not equal to IPFS, but in this particular instance, it's a similar thing that happens. Less popular content stops being torrented. You stops being seeded. You stop being able to get it. So obviously, we also don't want to be paying a centralized server in the Web3 world to provide this content, because we end up with the same resilience problem we started this whole process with, as well as creating vendor lock-in and losing the trustlessness we've gained. So for those playing at home, yep, you guessed it, this is exactly where Filecoin comes in. Filecoin is designed to leverage crypto economic incentives to keep this data distributed, reliable, and persistently stored. So as we go along, and I'll say a bit more about Filecoin, I encourage you to play along with a little segment I like to call Filecoin Mythbusters, because there's a few myths going around about Filecoin, so hopefully I can dispel a few of those today. And the first one is Filecoin is not IPFS and IPFS is not Filecoin. So we've already got rid of that one though. Anyway, so what is Filecoin? Filecoin is architecturally designed to leverage a cryptoeconomic incentive model together with cryptographic proofs in order to ensure data is stored persistently, highly reliably, and verifiably across a distributed network. So its use of these cryptographic proofs also enables smart contract-based permanence, and it means that it's designed to be as permanent as you, the data owner, want it to be. So whether that permanence requirement is for 500 years or for 5 minutes, you have total control over the time frame you want for your storage. You also have total control over how many copies of it you want to ensure for resilience. And it's so you could have one copy, probably not very resilient. You could have 100 copies. It's really up to you how many copies you want to store. So it gives the user back control over those things as well. So Filecoin is also designed to be hyper competitive on pricing, and that's due to the distributed nature of storage and the economic reward model, as well as the efficiency of the market. I think the last stat I saw, I know there is one up there as well, but maybe a better stat, the last stat I saw was it works out at less than $4 a month for 1 petabyte of data. Which is like roughly equivalent to 5,000 times cheaper than AWS. And that's not due to, that's not taking into account the deals that are currently in place that make data storage free or anything either, or the incentives that obviously are going to wane over time. This is designed to stay cheap forever due to the incentives. And if you do want to learn more about how that actually works, I encourage you to dig a little deeper into the docs and how those incentive models and smart contract things work. Anyway, so the network also has internet scale capacity. So currently we're at 18 million terabytes. I honestly don't even know how big that is. It's some crazy number that my brain can't compute, but it's approximately equal to 1% of total cloud storage capacity, and it's growing at a really rapid crypto pace. So that's kind of enough storage to store 135 copies of CERN's data, which is the European Organization for Nuclear Research, by the way. Pretty another interesting stat. Um, Anyway, so it's enough capacity for almost any use cases, and there's already heaps of organizations and people using Filecoin to store data, and even some companies creating roadmaps for commercial models built on Filecoin. I spoke to a company the other day that it's looking at building solar server farms here in Australia around IPFS and Filecoin storage, so pretty awesome. Anyway, how does all this work? A little bit about the Filecoin storage deals. So to make it work, Filecoin uses Filecoin storage deals, and this includes two main consensus mechanisms that ensure both rewards for good actors in the system and penalties for bad actors. So firstly, when you make a deal with one or more storage providers, the provider generates a proof of replication, which proves the storage provider is storing a unique copy of the original data. Over time, providers must prove that they have random subsets of this client data and create proof of space-time. And anyone at any time can check for this proof of space-time as well. So this proof is the mechanism by which miners, or really storage providers or services, are incrementally rewarded with Filecoin. With the Filecoin token, I should say. So since these users must also stake Filecoin as collateral to join the network, if they don't provide these proofs to show they're still storing this data, they're penalized. So this dissuades people from undesirable activity. We're all about carrots and sticks here. Well, I don't know how much of a reward a carrot is. Maybe cheesecake and sticks? Anyway, and no sticks, just booing from the sidelines. I don't like sticks. Anyway, when the storage deal comes to an end, a user can opt to let it expire or renew the deal. If they opt for renewal, then providers will bid to host this content. So here's the market creating efficiency for pricing. So that's the basics of how a Filecoin deal works. And this is what builds in not just data permanence, but also data timeframe sovereignty. So again, you decide if you want to store your data for 5 minutes or 500 years through this deal. And we're also, and you can enable this in a smart contract. So anything could continually renew this if you wanted to. So you've definitely got multi-generational timeframes of storage there, or you can just store something for 5 minutes if that's all you want it for. So it also you also have sovereignty over how many copies of that immutable IPFS data, potentially immutable IPFS data, you want to have, and on what providers. So not only does this deal making structure allow for an efficient market, but it kind of opens the door for you to comply with regulations like GDPR. And there's like kind of a few tools out in the ecosystem, such as Bitscreen, that allows you to filter your deals for what's relevant to you, like only having your storage providers be in Europe. So there's also a lot of opportunity to build toolings in this space that will help with all sorts of things if you're interested in getting really deep on this as well. Just as a side point though, IPFS is storage layer agnostic. So this means that you can combine it with the storage layer of your choice. That could be Filecoin, which, I personally think is a great option. Not biased at all, but you can also store your data with a centralized cloud storage provider or any other decentralized storage solution. So if you want to use IPFS and then a store on AWS, or IBM Cloud. I don't know who uses IBM Cloud. You totally can. That's the point. You can store it anywhere. But for permanence and resilience, we'd suggest Filecoin. So this is how IPFS and Filecoin fit perfectly together. It's like developers at a developer DAO hack. Yeah. But yeah, so IPFS is not Filecoin though. They're complements, but IPFS is a protocol, whereas Filecoin is a blockchain. So hopefully I've busted some of the myths that you may have had about Filecoin. We also know how IPFS and Filecoin are different and how they complement each other. So is Filecoin and IPF hard to use? That next. So I want to move on to the, IPFS and Filecoin are not easy to use one. This one is not entirely inaccurate because using these kind of in-depth protocols and blockchains at the base layer is a challenge, even for highly skilled engineers. If you do want to work on this base layer and contribute to it, though, we are always open to that. There's a number of bounties and grants available in this space, and we'd love to see extensions to the open source protocols, as well as more projects that make it easier for developers to use or to solve a need in the ecosystem. So that is definitely always open to you for those of you that want to do that. But for those of you that just want to build out of the box, and this is definitely a camp I often fall into, there's a bunch of dev tooling options for you to use as well. So this kind of gives a good overview of some of the abstraction layers out there, this slide, that make it easier for you to leverage the immutable address system of IPFS with the permanence of Filecoin storage for your projects. So one of the first things you might come across is, how do I access IPFS CIDs in my browser? And you do this using a HTTP gateway, so an IPFS HTTP gateway. And if you're using a browser like Brave or Opera, they have fully integrated IPFS into their browsers, and so you won't even need to go to a gateway to get through to them because they automatically do that for you. They've integrated IPFS. So Brave and Opera coming up as legends of the Web3 world again. If not, though, you will need to use an IPFS HTTP gateway, like on Chrome or Firefox or any of the others. And there's a bunch of providers for these, including IPFS itself, Cloudflare, Infura, and Fleek. Who's Fleek, you might ask? Well, I'm glad you did. So Fleek is one of the first dev tools I want to talk about, and one of my favorite IPFS projects. So Fleek is a CI/CD tool that you can use to deploy your apps for free, as simply and as easily as you would with some of the Web 2 tools that you might be familiar with, like Netlify or Vercel. The big difference is, though, that Fleek uses IPFS to host your site or app and even offers ENS domain routing on the platform. So I'm going to take it as a win if the only thing you get out of this talk is to go and try out Fleek and host your decentralized front ends or apps on Fleek rather than a Web2 alternative. If you don't 100% love it after trying, I'll give you your money back. Just kidding, it's free. So another one of my favorite tools is NFT.Storage. So you may have found that storing your NFT data, metadata immutably and permanently, if you've played with NFTs at all, there's a metadata field that basically you need to give it yourself. So that data could be stored anywhere. It could be stored on HTTP, which is not immutable. It could be, if it's not IPFS content addressed and then stored somewhere where it can be multi-generationally, stored, then you're really defeating the whole purpose of an NFT. So NFT.Storage was specifically created as a public good to archive and persist NFT data, and it takes care of the complexity around firstly creating an IPFC ID for your NFT metadata, and then it makes an automatic deal to store this content persistently on Filecoin with 8 or more times redundancy and with a multi-generational time frame. And it's all currently free to use, and you've got that guarantee of like permanence as well as redundancy in it. So over 25 million NFTs are currently stored on NFT.Storage and constantly growing, and it's used by both OpenSea and Magic Eden, to name a few. So this is not a small experimental project. This is an industry standard. And it's free. So if you are interested in using this one or you're doing an NFT project, I've also got a little starter kit demo on GitHub and video on this topic that you might want to have a look at too. So what about data that isn't NFTs? This is kind of where Web3 storage comes in. So Web3 storage is another project that was built by IPFS and Filecoin and designed to give you all the benefits of decentralized storage and IPFS content addressing with the frictionless experience you kind of expect in a modern storage solution. This is also free to use for up to 1 terabyte of data, and it's compatible with both JavaScript and Go client libraries. You could also use this for your NFTs if you wanted to, but the two projects have very different future roadmaps. So Web3 storage is the place to go if it's not NFTs you're looking for. Sorry, there's also a blog post on how to choose up on our Filecoin blogs if you want to have a look at the difference between those as well. The next tool I want to mention is Powergate. So Powergate is for more advanced developers. It's a Docker container that's wrapped around a Filecoin and IPFS node, and it gives you a lot of options to configure minor selections and extend the functionality of IPFS, Filecoin, and live peer-to-peer. Textile also offers, so Powergate is by Textile. Textile also offers a Polygon bridge, which might come in handy for this hackathon as well. But this is really an in-depth tool, so if you're one of those developers that likes to go really deep down the rabbit hole, this is probably more your bag than the first two. There is more tools out there, and there's probably one of the biggest questions we get is what about like kind of a relational database? Relational databases in Web3 aren't fully fleshed out yet, but if you do want to try one that is a work in progress, OrbitDB is probably a great one to start with. There's also Ceramic, which is another kind of version of what we're familiar with as relational databases. But a few of the problems associated with relational databases really aren't solved yet. We are working on them, but are not fully solved. So there's also Lighthouse.Storage offering another dev tool for you, like Web3 storage a little bit. And Filebase is now on IPFS, and they are currently integrating Filecoin as well. So that might be good to know for this hackathon, because I know they're also involved. There you go. So hopefully we can tick the hard to use item off the myth list here now too. And maybe this is the start of a new show, Blockchain Mythbusters, anyone? I could rock a beret, right? No, I'm just kidding. Let's not do that. Look, honestly, I really hope I've actually given you a good understanding of the IPFS and Filecoin mental model and architecture layers now too. Because there's heaps of opportunity in all these different layers. So there's the standard application logic or smart contracts. And by the way, there's one that I'm super excited there for as well, but I won't give away my talk. The logo on the far right is special Filecoin one. But anyway, then there's the storage helpers, NFT storage, Web3 storage. There's also Estuary, coming up. And I think that is Slate. I'm actually not sure what that last one is. And then there's the nodes themselves. So, storage is such a massively fundamental component of all our systems. So there's so many use cases you could dive into here. Speaking of use cases and projects, I've kind of compiled a few of them together here. And this diagram is actually way out of date, but it does give you an idea of the growing list of both Web 2 and Web 3 products and services that are utilizing IPFS and or Filecoin. So this is way out of date as well. I actually couldn't find an updated one. So I think this is like definitely 6 months old by now. Anyway, so one of the biggest use cases for IPFS and Filecoin is obviously NFTs and the metaverse. Because with IPFS, we can create those immutable references in our NFTs. So no matter where the content lives, it can be retrieved. And with Filecoin, we have persistent verifiable storage that allows us to store massive volumes of data. As well as additional copies in other places. So Filecoin gives us that persistence guarantees that even if your computer or your favorite IPFS pinning service were to go away, the content would still persist. Onto some of the awesome projects that are on IPFS and Filecoin as well. There are so many out there. One of my favorite ones at the moment that we're actually trying out in the office is Huddle01. So Huddle is built off IPFS and Filecoin and is like a new Zoom. So they're working on making Zoom but on Web3. So definitely recommend going and giving that one a go. Huddle01.com. So Audius also uses IPFS and Filecoin. LivePeer under the hood as well. OpenSea, as I mentioned, is using NFT.Storage for their minting service. We've also got some social good ones out there, the Internet Archive, Starling Labs, and there's some open data on Filecoin from New York City subways as well. So talking of social good initiatives, like those three, and I kind of skipped over them because I do have a few more slides on them later. The first social good, or the first thing we're doing, because this is what we believe in as well. This isn't just a, social good initiative, but this is where we believe we should be going. We're seeking, firstly, to make Filecoin sustainable, and we're doing that with a project called Filecoin Green. So this is an initiative that is seeking to make Filecoin blockchain carbon neutral and in time carbon negative even. So a lot of the conversation around blockchain technology these days and climate issues is focused on the energy expenditure of proof of work chains. But one of the things that's really not discussed very often is how the development of Web3 actually enables more transparent tracking and accounting for these green technologies. So that's something we're passionate about and putting our effort behind here. And that was just my niece knocking at my door there. But anyway, so we've also joined the Crypto Climate Accord initiative, and we welcome feedback from the community on this initiative as well. We've also got our talks up on YouTube about what we're doing here as well. They're all open. So another part of Filecoin Foundation is the Filecoin Foundation for the Decentralized Web. So this is a non-profit organization whose mission is to ensure the permanent preservation of humanity's most important information. It does this by stewarding the development of open source software and open protocols. For decentralized data storage and retrieval networks, and it focuses on charitable activities related to preserving important data sets, which is probably quite a lot of around, and you can think of many different causes that would need this. It also funds research and development, and it educates the public about the decentralized web. Danny is the steward or the main driver of this program, and he's amazing. He's been around since Web 1, and he's seen where things go wrong, and he doesn't want to see that happen again. This is run by a governance council as well, so it's not a centralized point of contact there either. The next thing I want to talk about is Filecoin Plus. This is aimed at incentivizing storage providers to store valuable data sets on Filecoin by rewarding storage providers with up to 10 times the block rewards for verifiably storing these valuable data sets. And again, we use a governance council to decide on what's viewed as a valuable data set. And then storage providers are able to bid to store these data sets. So this provides a unique method that can cause these deals to be free or even negatively priced, because the storage providers are getting rewarded so much in block rewards for these. They can price them negatively in order to secure that deal. So there's a lot of examples around Filecoin Plus, and where we're doing work with storing valuable data sets, and if you do have a valuable data set, you can apply to be part of this program as well. We also have several social good use cases. I think I'm running low on time here, so I'll just skip through a few of these, but some of them are our partnership with Starling Labs, we're working on resiliently storing the testimony of genocide survivors on Filecoin. Internet Archive is also collaborating with Protocol Labs to onboard 2016 Enterprise Residential Term dataset, 200 terabytes in size, to Filecoin. Researchers and devs from Colombo University are using IPFS and Phil for climate data, to make this available to climate researchers. Gainforest is also working on natural sustainable stewardship, and it uses IPFS and Filecoin as well. And OpenScientia is building a scientific ecosystem around Filecoin and IPFS as well. So there's some awesome social good use cases that are out in the wild already. Anyway, so what's next on the IPFS and Filecoin StarMap? Well, the big one this year is the Filecoin virtual machine. So the FVM, and I'm super excited about this one because this is due to be released in Q2 to Q3 this year. Summer in the northern hemisphere, winter in our southern hemisphere, kind of time frame. I'm super, storage and smart contracts really make sense. So FVM is going to bring out FVM, I should say, is going to bring the general programmability, if I can get my words out, of EVM compatible smart contracts to the Filecoin blockchain. So storage plus smart contracts. There's so many things we're going to be able to do with this, and we're currently working with a cohort of early builders to help test and deploy this community as well. So that is something to really look forward to, and is really going to grow the ecosystem a lot, as well as your use cases and ease of use of using IPFS and Filecoin as well. Super exciting. So what are the possibilities? What can you at this hackathon build if you haven't already been inspired by some of these projects? Well, there's 11 project ideas here that you can have a quick look through, but you could do something around videos, social networking, the metaverse and NFTs, GameFi, really the sky's the limit there. If you do want to get inspired by some of the past winners of some of our hackathons, you can check those out at hackathons.filecoin.io and see what some people built. One of the things to really think about is, ask yourself the question, what data needs to be persistent? What data needs to be verifiable? What data needs to be immutable? What in the Web 2 land needs to be censorship resistant and resilient, but that maybe currently isn't? So what things lend themselves to this, or could be enhanced by better indexing on IPFS, indexing or addressing, I should say, methods, or by more resilient and persistent storage using Filecoin. So take things to the next level and, try and color outside the lines a little bit. What might also help you think about things is consider the different layers of storage and addressing. So this is a great diagram here. So user and client interfaces, there's smart contracts, there's compute, consensus, hardware, and networking. As you're building, you can consider that, you don't just have to build a dApp. You can feel free to dive deeper into some of these layers because IPFS and Filecoin really introduce a whole new economy with lots of opportunities to create new ventures at pretty much every layer. So that's why I really like this visual. So it's not an exhaustive list either. And hopefully I've got you a little bit excited about some of the possibilities of this ecosystem and given a bit of an explainer about what we do here and what we're seeking to do here. So I'll leave you with some resources and how to get involved. So firstly, there's a bunch of learning resources, Proto School, NFT School, our docs, obviously, our YouTube. We try and work in the open as much as possible, so you can even see all of our all hands meetings there, open governance meetings there. Michelle Lee, aka Mosh, has a great grants video up on what grants are available for you, and that's not just like micro grants for after your hackathon, but project grants and bounties for really hardcore developers as well. And get in touch and stay involved. There's our Discord, our Slack. We've also got an ambassador program that we've recently launched. If you do want to be part of the community and help, educate people around IPFS and Filecoin, and that's a great thing to get involved in as well in your local area. So we'd love to have you on board. We have developer advocate office hours and a weekly gather town, and stay informed with our newsletters, all the regular stuff. We've also got, always part of events. So you can, get to know us more at any of those. I'll be at South by Southwest next week. If anyone's there, please come and join us at our NFT house, which will be at the Graber between March 10 and 15. There's Eth Global is holding Build Quest, which we're a part of, a Game Jam and Metaverse hackathon if you're not sick of hackathons after this. So there's so much going on in this ecosystem that you can get involved with. And I've given you a kind of an overwhelming amount of information in a short time. So thanks for bearing with me. And hopefully, like I said, I've given you some inspiration of what you can do. But thank you for being a part of creating both history and the future here at the Developer DAO inaugural conference and hackathon. And kudos to you guys for being involved. I can't wait to see what you do with your projects.